Well, welcome to Radio Engines 101, I think I'll call it. My name's Hunter Harris, Hunter H. Harris. And because of my interest in radio engines and what I've seen over the years, when people see my radio engine on my airplane, it's obvious that there's a great interest in this design of an airplane engine. It's less and less used less than whatever the proper is. But the key thing is there are fewer and fewer people that know how to work on these things because they are very unique. And that's the beauty of it. I'm a motorhead. I'm a farm boy from the Eastern Shore. Been pulling wrenches on farm equipment since I can remember. And one thing led to another. I'm a commercial pilot now. I have a commercial license for every category of aircraft that exists. And based on, and it's a commercial level license for all these different helicopters and gliders and jets, and of course airplanes, seaplanes, airships. And I'm also a licensed aircraft mechanic. And the level above that is what we call IA, inspection authorization. So I'm an licensed inspector for the work that a licensed mechanic can do. So I can sign off anything just about. And I've never been in the military. It all stems back to pulling wrenches on old Alice Chalmers tractors and all. You gotta start somewhere. So over the years, I've spent most of my time flying interesting aircraft all over the country mostly, but in other countries also. And eventually I made my way back home again. And while traveling, I always noticed people having fun all over the country giving biplane rides. I said, I'm gonna go home when I get off the road, and averaging 200 nights a year in a hotel was, for over 10 years, became very old, flying blimps around. So I came home, bought a Stearman, started hopping rides. This is 12 years ago, you may recall, blue and yellow Stearman here at the Houston Airport. And in 5 years, I carried over 1,500 people, one at a time. And never had a problem, nobody ever got sick, just a lot of fun. And then 9/11 happened, and we were very concerned about what's the airspace going to turn into. Nobody knew. And I sold the airplane, and the price was far too low because it sold in 3 hours. But anyway, so time goes by, and I had other airplanes with round engines I was flying for other people, and that worked out fine. And then they disappeared, and then suddenly I woke up and said, I don't have any round engines to fly. And I went out and bought another Stearman, the one you'll see here in a little bit. I've had it now 4 or 5 years. And so anyway, still into my round engines. So what I'm going to do today is introduce you guys to the basics of a radial engine. Like I said, they're very unique, everything about them. So I'm assuming everybody's somewhat of a motorhead. In other words, they've been inside an engine and so forth. Well, this will introduce you to a configuration that's unique to probably what you've seen in the past. And I think you'll find it interesting. So radial engines are round engines, not to be confused with a rotary engine. A rotary engine is round, but when it's used on an airplane, a rotary engine rotates. And with a propeller mounted on the airframe. So it's a propeller and the engine rotating around. Used World War I and not that much during World War I because too many moving parts. And not that reliable. So the radial engine, which is a fixed engine with a rotating crankshaft that turns the propeller, is what became more popular, far more reliable, and it evolved over the next 30, 40 years from small 100-horse radials all the way up to the biggest one that was mass produced. It was the Pratt & Whitney 4360, which were 4 rows of 9 cylinders, 52 spark plugs, and around 4,000 horsepower, big engine. And they call it the corncob engine, but it had some issues. You can imagine an air-cooled engine that's very deep with 4 rows. By the time the cooling air gets to the rear row, it's not doing a lot of cooling. So there was enhancements and so forth. Incredible engine. There's only 2 airplanes in the world right now that continue to fly with a 4360. It all has to do with economics. Spark plug, 52 of them, averaging, the cheap ones are $80 a piece, you know, and the maintenance is incredible. Anyway, so what I've been dealing with most of my aviation career are the smaller ones. And my favorite being the one I'm going to share with you today is the Lycoming R680. Lycoming's up in Williamsport, Pennsylvania. They built a lot of interesting airplane engines. You know Williamsport? Yeah.
Grew up, yep.
Okay. They actually built the largest radial engine, but it wasn't mass produced. But it was big. It's over in the Smithsonian, by the way, if you want to see this monster. But anyway, they went through, like every other manufacturer of radial engines, a history of evolution as time and experience showed weaknesses, they improved, and so forth. This engine, the R680-13, is probably the pinnacle of that particular Lycoming 9-cylinder engine, as far as improvements and reliability and so forth, and probably the most produced. So I'm going to show you a video here. It's not a Lycoming, it's a Continental, and it's not a 9-cylinder. The poor thing only has 7 cylinders. It's more popular amongst the steerman people because it was the most used. They did put, from the factory back in the day when steermans were used for trainers, most of them had the 670 Continental. Many of them had a Lycoming R680, but of a different horsepower and a different design, which eventually evolved to what we have today. And but when I go to the steerman fly-ins out in Galesburg, Illinois, and Oshkosh and stuff, most of the purists want to see that engine. They don't like me and my engine because I got a big Lycoming with a cowling and a lot of other modifications. You might think of it as a full-dress Harley, you know, in a way. But the performance of my airplane leaves them in the dust, and that's what it's all about for me. So we're going to watch this video, and it'll show you the workings. Now it's a French-made video, so there's not going to be any, unless you want to hear it in French. But I'll speak a few things as it goes along, and we're going to see the inner workings. And what I want you to pay attention to is the configuration itself, meaning the crankshaft, which there's one over there, and how it has all the rods on the same plane, and how this thing works, and how smooth it is because of the firing order. One thing about radial engines is 99.9% of them have an odd number of cylinders. So the key is the firing order. We always start with number 1, which is up on top. So it's 1, 3, 5, 7, 9, 2, 4, 6, 8. So the firing impulse just goes around like this, and it has a lot to do with balancing, harmonics, and everything else. And that's why it has such an incredible mass weight on the crank. So when you look at this video, you'll see that thing going around, and you may notice that some of them show the sparks going on as it goes around like this. And all this comes together to make this incredible sound, which I'm sure most of you have heard it. We're not going to hear mine today for many reasons. It's come down to, I'm not ready. We're waiting for some parts, but in the near future, and if you're interested, we'll notify you when that happens, and you can welcome to come back out, and we'll go up to the hangar and we'll fire it up, and so you can have that chance to hear the music. So let me see if I can make this work. Let's see if I can get. Oh, wait. All right, so there's a 670 7-cylinder on a Stearman with a wood prop. Mine has a controllable prop, only 7 cylinders. That's the back, behind the engine, big oil tank, dry sump system, air filter, and exhaust pipe. That's the data plate. So here's a nice computerized. So here's the ignition system on the back side, those 2 black magnetos. 2 spark plugs per cylinder. Each one has its own mag. And so that's redundancy more than anything. So here we are, master rod on this one appears to be number 1, straight up. On mine, it's number 7. So see how the crank moves around with all cylinders on the same plane. There's that counterweight that's required to absorb what little imbalance there is. And that itself takes quite a bit of energy to spin. But it's required to balance things out. You got to keep harmonics happy. So there we are, up and down and out of the cylinders. Crank is spinning. Some of the bigger ones had a gear reduction box up there to reduce the prop shaft as compared to the engine RPM. But the smaller ones, the engine RPM is the same as the shaft. So they're the lifters riding on the cams. Roller lifters, see the rig cam lobes going around and up and down they go. That's one of the most interesting components of the design, is how these cams, which this one here goes 6-to-1, mine is 8-to-1. In other words, the engine, for every 8 revolutions of the engine, my cam only turns 1 revolution. And I'll point out why that is. So here we are, again, push rods, riding on the cam, opening, closing the valves at the appropriate time. And that's all evolved. Used to be exposed valves, which you had to go grease with a grease gun and grease the rockers and all that stuff. Now it's all enclosed, and engine oil will lubricate that. So there's a power stroke. It shoved the piston down, now it's coming up and the exhaust goes out. And the minute it gets to the top of that, it closes, and then the intake sucks in the new slug of air-fuel mixture. It compresses it, just like any 4-stroke. Spark plug, usually 30 degrees before the top blows up, and pushes it down on another power stroke. So that's no different than the average 4-stroke engine. It's just that if you were to see them all, it's an interesting sequence. So, and then I'll try to remember to point out something else when we finish this video. So there we are, the whole mechanism, monkey motion going around and around, creating this incredible sound. There's the firing order going on. And this order and that design and those 4 lobes on the cam, those bumps, 2 rows of them. One row of 4 lobes is for the intake and the other is for the exhaust. And the ratio of that cam turning compared to the crank turning has a lot to do with your basic maintenance on valve adjustment, because these are not hydraulic lifters. You've got to adjust them to about 15 thousandths. And so when you go around and you adjust all the cylinders at top dead center, you got to go around another 8 times, because each time you adjust it, it's riding on a different lobe. And each lobe will have a little difference in dimension. So,
so you're averaging.
well, you don't want the valve staying open. So you choose the one that's the highest value, and make sure that the valve's going to seat solidly, because if you don't, you'll be burning out the seats and so forth.
With the crankshaft actually revolving, how do you get out to the propeller on a non-revolving shaft? I mean, you can't drive the propeller doing this.
No, if you notice the shape of the crank, the master rod rotates around.
Right.
The center of the crank is the center of that picture right there.
Okay.
It's the center of rotational mass.
Okay.
And the bearings supporting it front and rear. And all right, so there's that one. And then let me see something here. I don't want to stop that. Here we go. I received this yesterday from my buddy who is Radio Engines Limited. If you really want to learn about these things, this guy Steve Curry has a whole bunch of YouTube videos, details of these radio engines. He and his son are out in Guthrie, Oklahoma, and I've been working with them for years. They are the best, the world's most recognized professional radio engine shop for the smaller ones. And the 670 Continentals and the R680s. And they, not only do they rebuild them, but they have a team that's developed over the years. They have, they've created these videos, which are very educational if you have the interest. And they've actually gone beyond original designs and come up with what we call STCs, working with the FAA on improvements to these old engines and old designs. And my engine, which they rebuilt a couple years back, has some of their new modern adapted, for example, my ignition system, scavenge oil system. He's threatening to create a fuel injection system for this engine, which I can't wait, because right now it's an updraft carburetor. And despite the beautiful impeller design and everything, the carburetor, I mean not the carburetor, but the intake system has a really hard time delivering the same fuel-air mixture to every cylinder. It's like anything, the air it goes to the distance or the direction of least resistance. So the cylinder right next to the carburetor is the leanest because the air's got to go up and turn around. And anyway, so he's going to do fuel injection, which he's done on a Jacob engine, and it's just made it a lot better performer. So let me hit play on this. So here's a video he sent me yesterday showing the same thing. If you look closely, that's the master rod, the yellow one. And see the red sparks? That's power stroke right after that. And around they go.
So the master rod has no connecting rod pin at the bottom. I'm looking.
No, it is where all the others connect
to
with
okay.
a pin. Yeah. And I'll show you all that over here on the table in just a moment. So radio engines, so that's the end of the video. And I left my notes at the office, so don't worry about it. Radio engines, of course, are mounted vertically, and they have lower cylinders. So one of the biggest challenges with a radio engine, especially as they get time on them and have a little wear, is when they're sitting static, oil within the engine will settle down with gravity. And if rings are worn and position of valves and stuff are in the right place, the excess oil that's within the engine could settle into the sump. Two things: it could bypass the sump by this normal plumbing between each cylinder. See those tubes? Those are to drain the rocker boxes all down to the lowest rocker box. And the lower rocker boxes could fill up. And if a valve's open, it would just continue to fill up into the cylinder. So if the volume of oil in one of these lower cylinders exceeds the amount of space when it pistons at top dead center, you can't compress oil. You get what we call a hydraulic lock. And the results of a hydraulic lock are just devastating. Sometimes you don't even notice it, it'll just bend a rod, and then it'll keep going for a little while and eventually explode. But that's why you see people with a radio engine, before they start, they pull the prop through. They're not wanting the rubber band, which is what I tell people. What are you doing that for? So I got a big rubber band in there, but you pull it through, and in time you learn how to listen. And if you hear gurgling, we got some oil in one of these lower cylinders. And you can tell if it's hiding behind the intake valve. And if it is, you can actually drain it back into the cylinder. before I had the oil drain system that's on there now, you would have to remove a spark plug and let it drain out. Or, and it's a mess, it takes time. With a cowling, it's a real nuisance. But I have a new system on there where I can turn a valve and that it'll drain out. So,
What did they mean by blowing a jug?
Blowing a jug could happen, it's a generic term, meaning we just had a failure on the top end of the engine. So it could have been because of a hydraulic lock. It could have been. That's where most stresses take place, is in that high heated area. And the casting, this is steel up to here, and then that's aluminum. And so that's a threaded joint. That can fail too with stresses, different kinds of stresses. They can crack. There's a lot of things could happen. Another thing is these bolts right here, where these are nuts on studs, they hold the whole assembly onto the crankcase. Those have to be checked on a regular basis for proper torque. And on the R680 with the normal ignition system, which I don't have, it's inaccessible. You got to pull all that stuff apart, which nobody wants to do, to check these every 100 hours. And they've got a reputation of losing jugs. And the reason is, if you look in the books, the log books, they've never checked torque on those nuts because it's a pain. So I've made modifications, and I'll show it to you, where making those checks, and we just finished that, is far easier, and we can do it every 100 hours. And I've done it now 3 times, 250 hours on that particular engine. And it does change. It's not that they get loose, it's just that things change shape, actually. So, you know, they get a flat maybe, it's only 25 foot-pounds, but you got to keep them equal. And that keeps the loads all the same and everything else. So, but that's a good question, because that's a term you hear a lot. The next question you should ask is why? Of course, during the war, they were shot up. These things would blow jugs because they took a round and they keep right on running, you know. It's some of the stories of these things coming back half blown apart. It's just amazing. These cylinders are so independent. So, so that's your video. There was something I tried to remind myself to tell you about, and I forgot already. So let's go look at parts, and you can ask me questions. Are there any questions right now? Yes.
When I was a kid, Allegheny Airlines flew DC-3s in and out of Williamsport.
Mm-hmm.
At the start of the engine, there was a ground crewman with a fire extinguisher. Why?
Well, as I kind of hinted to, the induction system on these things with a carburetor, this is before fuel injection was known, or fine-tuned, you might say. They would often, if they had over-primed it manually, which is what you have to do on a cold start, and some warm starts, you could flood it, and if you had a backfire, it would fire through the induction system, which leads it backwards into the carburetor and into the intake system. So the deal is, and I've had that happen, and you can't see it from the cockpit. That's why one reason they're there is, and if they go like this, all of a sudden it means you got a fire. Keep it cranking, and you'll pull it into the engine, and it will extinguish. Unless the engine is soaked in oil, and that took a light. So it's always good to have a fire watch. Primer line could break, and maybe create a fire from ignition source, things like that. But it's a real good safety call. So I had a fire up here at Easton Airport at the front of the terminal with the other steerman years ago. And I had a passenger in the front, and I just started it off, primed it and cranked it. And I said, why didn't it start? And then somebody started waving. I said, oh my God, just about then the battery went with it. So I couldn't pull it through, so we had a fire. So I got out quick, got the passenger out, and they had this old-fashioned World War II fire bottle on these big wheels with some chemical compound it's nobody would touch anymore today. I think it's ABC. So that's all I had, so I rolled it out there, and the whole airplane turned white. But it put the fire out. now I'm left with this very corrosive material all over the airplane. So it's not what you use at airports. There's different combinations for that. Anyway, but it was there, it prevented the fire from spreading, but it took 2 weeks to clean it up. Yes?
You have dissimilar metal, you have steel, and then with the aluminum, I assume aluminum fin for issues there. It's a threaded connection.
Yes. Yes. There are no issues, but there are concerns. And the reason why we use different, so we have steel, aluminum, and magnesium. That engine there, that nose cone is magnesium. Each one has a separate set of thermal properties. And since the range is not that large on an air-cooled engine, unless you have an issue, they do change shape, and that's why you got to recheck torque and all on the hold-down bolts. The major assemblies don't change that much as far as the torque settings. Only the cylinders are kind of exposed. But as far as any other concerns, I can't think of anything that thermal shock is the big concern. That happens when you're high temperature on takeoff, full power, and temperatures go up rather quickly. And then you typically would reduce as you level off for cruise. And then as you make a descent to the airfield, you're coming back on power. And things change temperature-wise slowly, not a big deal. If you thermal shock it, in other words, your altitude, and for some reason you gotta get on the ground in a hurry, and you pull the power back quickly. You go from normal temperatures at cruise to suddenly the components like the cylinder heads that are most exposed to ram air cooling, they start cooling off real fast. And the inner parts don't do so as quickly. That can create all sorts of problems, thermal shock. Yeah. Any other?
I just wanted to mention, you talked about that 28 cylinder radial engine. There is a cutaway of one at the Dover Air Force Base Museum. So you can actually, press a button, you can watch it.
Wow.
The parts work.
I gotta go see that. It's hard to believe.
Yeah.
Yeah. You had a question?
Yeah, avgas versus jet fuel. I retired from the Pentagon when they were just looking at buying light attack aircraft. And I was looking at their performance and scratching my head when comparing it to World War II fighters, till I found out that they made a turboprop P-51 and it had much lower performance than that. So I'm assuming that avgas engines just put out much more horsepower per pound than turboprops.
Well, the term is thermal energy per cubic meter or whatever. But anyway, the two things you mentioned, that Mustang prototype was an airframe, a Mustang airframe. They pulled the Merlin out and put a big Rolls-Royce Dart engine, which was an early version of a turboprop. And it had nothing to do with the fuel, it was the engine performance.
Okay.
But it burnt Jet A. And, but there's two different completely type of engines that burn two different completely types of fuel. There are a few turboprops that in an emergency are allowed to dump 100 octane in it to get out of town or whatever the case may be, but you don't want to do that too much because of the thermal energy per cubic whatever is far more, so their temperatures, their internal temperatures go up a right good bit, so you gotta keep it under check. But Jet A is the standard today for most aircraft because of the type of engines. Also, with the smaller airplanes, Jet A burning engine is more desirable because it's available internationally. 100 octane is really hard to find. In fact, they're going to outlaw it in California soon, which is crazy. And they claim that all the kids in elementary school can't learn because of the lead in the 100 octane. And they're serious about that claim. But anyway, they're going to remove, it's the only fuel that we use in this country today that still has lead. The reason is airplane engines need it to operate their high compression engines. And the amount of devastating exhaust, I think is way overrated and so minuscule that it's, I don't know, I won't get into that. But anyway, we're having to deal with it. So, any other questions?
What is the compression ratio of a typical engine?
That one's 7-to-1, and that's why it's become the pinnacle of that design. It's got what we call a higher compression pistons, the design, plus the rod's a little bit longer. And the early versions of that, it was 5-to-1. So a lot more room. It had to do with the internal loads on the engine. They built it very conservatively at 5-to-1, and then they learned more, and as they got more comfortable with the integrity, things would increase. And now it's up to 7-to-1, and it seems to be a good balance. I'm sure I could put a bunch of bubble gum on top of the pistons and make it a 10-to-1 if I wanted to, but that's good enough. So, any other questions? All right, let's go over to the table. And all the other rods attached to these points here. And so while this is riding on this humongous bearing in the front and in the rear, here's the counterweight. And this splits also, by the way, which I haven't split it yet, but I will when I go to rebuild it. But anyway, so this is the mass that rotates, and this thing is heavy, let me tell you, for good reason. I think I'll interrupt myself and tell you the history behind this engine. As you will see, my engine on the Stearman right now, it's got 250 hours since it was a major overhaul. A major overhaul means that all components within the engine were checked for dimension, and they're all within new specification. So whatever the factory design, a pin, any surface, anything has a specification. So every component before it's put into an overhauled engine has to meet the original specification. You can't have any corrosion on any surface that would be affected by it. You know, a cosmetic on the outside is not a big deal, but a surface where a gasket or seal's required is. So my engine up there is built to that specification. Those components are good, but the question is, where did they come from? All right, so over the years, these engines have been used, rebuilt, reused, rebuilt, and in time, there are big bins full of used cylinders and cranks and cases at these engine rebuild shops. They put them through the testing. They qualify each component, but they lost their family from where they came from. You don't know the real history. How long has that thing been used? How many times has it been rebuilt? Some of the components are stamped to show that, but most aren't. So you get a component that still has a big unknown, but it meets the spec. So that's what I have, and I think that engine will last just fine if I take care of it. So years ago, I learned of an engine out in the deep Denver area at a crop dusting hangar on the east side of town. A friend of mine said, yeah, there's an R680 out there in the guy's hangar back in the corner. He claims it's only been rebuilt once. And he got the logbooks. I said, yeah, right. You know, and so I eventually called him, and nice fella, retired crop duster. And he said, yeah. He said, it really is. This is what it is. I said, okay, I'll be coming through town. Do you mind if I stop and take a look? He said, no, come on by. So I had to do a run out to California, up and down the coast to pick up propellers and other engine parts. And a buddy of mine's pickup, which I overloaded with all this stuff. And I came back by the way of this hangar. And sure enough, in the back corner, under dust, was this engine. And I'm looking it over, and you look at things, these stampings, where are they? Right here. This is the military markings of the history of when it was rebuilt, the date, the time on the engine, everything. And then he handed me the logbooks, which started when this became a civilian engine. So the military used it on a trainer, probably a twin engine trainer. For some reason they overhauled it and went into inventory, and then the war ended. And like a lot of that stuff, it was surplused out. And it became available to someone using the same engine on a civilian airplane. Probably bought it for $100. Unbelievable. And that's when the logbooks started, when it became a civilian. And the logbooks are very thorough on this thing. So I'm convinced that the history of this particular family of parts have lived together since brand new. And that's a unique combination of engine components. So I value that, and I bought the engine. He gave it to me for a really fair price, knowing it's got to be rebuilt. It's worn out. And it sat in my hangar for another 10 years. And I'm looking at it and I'm like, what am I going to do with that thing? And then I bought this other Stearman with the same engine. And a few years ago, my buddy and I said, let's rebuild it. I said, well, let's get started on it anyway. Let's see how good a shape it is by measuring and doing other things. So we dismantled it and got like, a lot of stuff here, you know. So we've measured everything. All the components have been soda blasted, which is a process that removes crud very safely. It doesn't affect any finish on the metal, any etchings, any stampings, or anything. It actually exposes stuff you couldn't see before. And so it's all been soda blasted, and then right away I get the soda blasting remnants off and then spray it down with preservation goo. And that's where we are right now with this stuff. It's a little sticky and all. So I got to hit it again here soon. So then I called the engine shop that built my engine I've been dealing with for years, and the shop I was telling you about earlier. I said, hey, any chance I can show up with an engine in pieces and work with you on rebuilding it? He says, yeah, but it'll cost you. And I said, oh yeah? I said, how much? I said, I'll bring donuts every morning. I'll do anything. And they laughed like you did. And so we made an agreement. He said, yeah, why don't you bring it down and we'll lay everything out, but we're going to send all the cylinders out to another shop. They'll rebuild. We're going to send all the components to a shop that does magnafluxing and real close inspections, looking for cracks you can't see, and the integrity of both the steel, aluminum, and magnesium components, and see what you have. And if it looks good, we'll call you. We'll get them all in the same room, and we'll start assembly. And that's when you ought to be here. So that's the plan. It was supposed to start in this past January, but I was reminded, you got to renew your flight instructor rating. It's 68 hours of online training, and I got to renew my inspection authorization every year also, and that's another 18 hours. So I spent January on the computer, so it didn't happen this year, maybe next year. But I'm looking forward to it, working with a team that's experts, because I really don't know anything, quite honestly. I'm familiar with the parts, and I'm happy to share all this with you, but I still don't know anything. But I will when I get back from this adventure. So, back to the stuff. So here's the main crank, and I suggest you, if you have a chance, just kind of wiggle it around and get an idea of the mass involved in that. So here's the main crankcase, and this is the back of it. This is a bearing here. This is the front of it here. So this case, which is magnesium, sits up here. And then underneath, well, let me show you more on this. So this is the front, That's a rear bearing support right there. And so the back of this is kind of interesting because this is the induction system here. So this, I'll show you more of the impeller and I'll show you part of this. This is where the impeller spins. It doesn't increase manifold pressure like some superchargers appear to look like that, but they actually increase the pressure, they supercharge the air. This is more of an impeller, a diffuser, so it kind of mixes like you mix dough or something. You thoroughly mix the air-fuel mixture, and then you distribute it as best you can to the different cylinders of these ports. So that's the back of the engine. This is aluminum with some inserted bearing cases. And then this is the nose cone. This is the main bearing support. There's the main bearing here. And if you look closely, you'll see holes drilled in it. You see these holes here? Oil. It's oil for a specific reason. So I didn't bring a prop governor. So what happens is the prop governor bolts on this area here. And regular engine oil pressure, which is at least 10 pounds per 1,000 RPM is the ratio. It'll take that into the oil chamber of the, it's a governor is what it is, and it'll pressurize it. And my governors are pressurized, or adjusted rather, for an output of 225 pounds, which comes back through these holes, into these holes, and fills this chamber here with the prop on it. So I control the amount of oil with a control in the cockpit that exits the governor, travels through the crank and out to the prop hub. Because at the prop hub, and you'll see this on the airplane, as the prop spins, the blades, because of gyroscopic loads, they want to twist certain ways. So what we do is we balance it with a weight, a fixed weight on a horn on the base of each prop blade. And then we control the effect of that weight with this oil pressure to change the pitch. So I control the pitch of the propeller blades, which you can relate to as shifting gears in your car. And in other words, at takeoff, I got full power, maximum induction pressure, maximum amount of fuel and air ratio hitting these cylinders. But I want to be in first gear. So that means minimal pitch. So that prop will turn on this engine 2,300 RPM, getting the most thrust in the right direction, getting the airplane down the runway and in the air. But as I cruise, as I go to a shallow climb and then eventually cruise, I don't need all that power. I don't need all that fuel. So the throttle comes back. The air to fuel ratio is reduced, the volume of it. And that volume reduces the amount of energy that's put into the crank. But at the same time, I can reduce the pitch because I don't need that. I can go to fourth gear eventually. And so the prop is against those counterweights, and reduced oil pressure allows the counterweights to bring it to a more coarse pitch. So it's a balancing act. It's very smooth. And so this is called a constant speed prop.
Okay, constant.
Yeah, and what you saw up there, you saw a big wood prop bolted on the crank. That's typical, very lightweight. There's no maintenance other than the integrity of the wood itself. But the constant speed prop you'll see up here has a fair amount of maintenance involved with it. And so this is the nose case. Prop governor goes here. Oil transfers through the ring. And here we have the base for pushrod tubes. I didn't bring any of those. So the push rods, of course, have to travel up to the, as you see in the videos we saw. And just on the inside of the nose cone, you pick this up when you get a chance. It's very light. This is where the cam, it rides in here. So the cam lobes and the lifters slide up and down in these holes here, and they're roller lifters, all machined obviously. And we have a drive here for the prop governor and some passageways for oil, high pressure oil, and a drain port. So this is the nose cone. Data plate, everything's got to have a data plate. Here's the magneto. This engine has, most engines, as you saw there, have two separate magnetos for redundancy, a left and a right. And of course, all engines have two plugs per cylinder. So one magneto would fire the forward plugs and the other magneto the rear plugs. This engine had, this is the rear case, has one magneto that mounts right here, this is the top, and two distributors. So the magneto provides the high amp spark to the magnetos, to the distributors, and the rotor button sends it out to the particular spark plug. So here's the magneto that slides in here, and these are the outputs for that cables. One output is for the magneto grounding switch in the cockpit, so we can ground and check that both sides are working correctly. And then the other is for the actual output. So there's two sets of points. And if you want curly hair, you can grab a hold of them and I can turn this and it'll put you on your ass real quick. But anyway, this turns slightly slower than the crank speed. So in the back of the case, I showed you the induction area, and that's where this surface matches up. So here we are. This is a nicely machined area that fits in the back of that, and within this, up against this surface here, this surface against this surface, but off about 15 thousandths, this is the impeller spinning around that's sending the fuel air mixture through those tubes. And then we have a dual tack drive. There used to be tack front and rear. There always is tack in the front and rear cockpit. Used to be cable driven. Mine are now electrical and far less troublesome and a lot lighter also. So rear case, tack drive, distributor drives, magneto pad, and then the oil pump goes right here. Oil is contained in a separate dry sump system. I'll show you the picture of that big tank on this airplane. It's 4.5 gallons and feeds by gravity at first, but then the oil pump will pull it in and pressurize it, send it through the crankcase, and the governor grabs some of it from here and does this thing with the prop. So the oil pump is a typical geared oil pump, and it's adjustable. The output's adjustable, that is. And
What weight and type of oil?
It depends on where and what you're operating. There's a lot of different theories, and I've run the gamut to test those theories myself. So we have multi-viscosity oil, which is a modern idea. Then we have the old-fashioned, one viscosity. And then you got to think about your operating temperatures outside, environmental temperatures. And so what that boils down to is a very expensive multi-grade 1560 Phillips, which, it's got to work no matter if it's hot outside or cold outside theory. It leaks through these old seals like you can't believe. So that's a mess. I got away from that.
So not synthetic.
No, it's
Still
not.
using
No, we don't
mineral.
use synthetic
So
at
you're
all.
still using mineral.
Yeah.
Why not?
Not approved. You can't do anything
No, okay.
unless that manufacturer goes through an extensive, expensive approval process with the FAA. You can't touch it. That's true with anything on an aircraft.
But theoretically, it might be good, but because they don't approve it,
Right.
you can't use it.
That's right. But personally, I'd be skeptical about putting it in there for a lot of reasons. The multi-viscosity taught me that these things are designed for thick oil, and the clearances throughout the assembly are so much larger than we see today.
Okay.
So much larger. So they allow for what was available for lubrication back then. You put this new oil in there, it'll just run right through there. It won't do any work. So you got to stick with what was on the table back in those days. And I'm back to that now. I run 60 weight, straight 60 weight, year round.
Whoa.
Yeah, it's called Airshell W120, which is a 60 weight oil.
Whoa.
And I run it about 50 hours and change it out. These engines originally had what we call a Kuno filter, which is right here. And a Kuno filter takes the output oil pressure and pushes it through a series of screens. And one set of screens are fixed and the other set are on a shaft. And every X so many hours you spin the shaft and it knocks out all the crud into a little sump. And you drain that every once in a while and you get all this carbon and the wrench you couldn't find before and other stuff. But I have a modern STC approved removable spin-on Champion oil filter. So, and it's 10 times more effective than the Kuno filter. And I spin my Kuno filter just to keep it happy, but there's nothing in there because the other filter's grabbing it all. And then when I'm done with that filter and change it out, I open it up, cut the mat out, lay it all out, wipe a magnet over it first, and then look at it closely and hopefully don't find anything suspicious. It's mostly just carbon. Some aluminum shavings, which are normal, and especially when it's a fresh engine.
So 60 weight oil, is there a preheater on the sump tank so you can start this thing when it's cold? Or?
You can put one on, they are approved. On my other airplane, I did have that on the sump.
Okay.
And I plug it in the night before. This airplane only flies on nice days anyway.
Okay.
So it's going to be okay. And as soon as I hit start or fire it up, I'm watching that oil pressure stabilize. And so it's a thought. That's when it's suffering the most. But remember, every time before I start, I'm pulling that prop through.
Right.
I'm priming the oil pump. I'm pushing oil. So it's getting a little pre-oiling, whether you like it or not. So here's another fun, interesting part of the whole engine. This is the camshaft. Isn't that wild?
Yes.
This one has a gear ring on it, and that gear ring is actually what drives that prop governor. It spins the prop governor. This turns at 1/8 the speed of the crank. And it has 2 rows of lobes. One row is for the intakes and one row is for the exhaust. Each ring has 4 lobes on it. So what's interesting is when you do a valve adjustment, which is standard, normal, regular maintenance, you don't just bring it up to top dead center and adjust the valves and be done with it. You've got to bring that prop through for another 4 complete cycles. And the reason for that is when it gets down on a land, this dimension could be different than this dimension. So you have to allow, you don't want to adjust it for one and have it not quite close on the other. So you allow for a little slop there. So it takes a while to do a complete valve adjustment program. A lot of work, a lot of oil, get tired of it. But anyway, so now we get up to the intake or to the cylinders. Very typical valves, intake valves, solid. This is the beginning of sodium-filled exhaust valves to spread out the heat that's involved with it.
When did that start? When did
I
this?
think during the war.
Okay.
I think these guys are early sodium valve people because exhaust valves.
World War II.
Yeah, World War II. Excuse me. But anyway, here's a 7-to-1 piston. They have evolved with internal structural reinforcement, oiling holes that the splash oil comes out and enters the oil control ring. This is the pin with the pin cap. These are aluminum. And this is usually what you find in oil filters is the aluminum coming off of this, which is typical. It's why it's there. It's sliding up and down in the cylinder. And So typical piston, here's a rod. So then the piston ends like this. It's a bronze bushing. This is the pin that goes on the crank, and has, again, a bronze bushing. And once they're all in place on the crank, there's a very important sequence which has been improved on the crank. All these little ears where all these pins are tapped into, there's a safety. The original factory sequence had heavy screws that were drilled heads that were safety wired together to hold.
I remember seeing the safety wire pictures of them on old plane engines.
Yes, well, that failed through vibration. So they have since, and it was years later, now we use a plate with bend over ears. And that's the way we lock those things in place. So when that came about, everybody's going like, whoa, what's my engine have? Because when those safety wires failed, the engine just ripped itself apart because these things slid out. And it didn't take but seconds that the whole engine just literally disappeared in pieces. And there were cases of that. They couldn't figure out what it was for a long time. It came out to be those safety wires. So then everybody goes, oh my gosh, what do I have? So there's different ways you can get in there to investigate the heart of the connection. Luckily mine is done the proper way, you know, since that service bulletin came out, and I have record of it.
When did that bulletin come on?
Well, it started off as a warning because they weren't convinced, and then it became a service bulletin, and now it's an AD, airworthy just directed. Now you got to do it.
When?
Oh,
80s, 90s?
no, 50s is when it.
50s, okay.
The 50s is when it, because these engines were popular with the crop dusters on a Stearman. They take 220 horse off, put a 300. They later took that off, put a 450 on it. Some of them took that off and put a 600 on there. And this is back when gas was 50 cents a gallon.
And the
too.
frame could handle
Oh
600?
yeah, that Stearman is like a tank. You'll see. It is amazing. So here's the cylinder with the valves out, because there's the valves. Very typical for an airplane air-cooled cylinder. What's amazing is we were able to read the original identification because there's so little time on these things. So we know the history, because that'll wear off in time. It just won't stay there. And upon investigation of the bore and the shape, it's like, it's better than new. So it needs no modern coating to reline it or any of that stuff. It, you know, we'll knock it down with a hone, and it'll be good to go. This bottom part's steel. That's steel, and the top part, which is threaded right, where is it? Under here, is aluminum. And then rockers go in here. The pressure for the oil for the rockers comes up through the pushrod tube. We have an exhaust, and this is exhaust, and that's intake. Here are two kinds of plugs. Massive electrode and fine wire. These are the standard, been around for a million years. These are relatively new. The wire, the fine wire that's there, you might as well call it unobtainium. It's a very high quality. Once it was platinum, but that didn't work out. There's a couple different alloys that have been used over the years. And the automotive industry's done the same thing, but it all began with aviation. These are now brand new, 50 bucks. These brand new are 200 bucks. Wow. So this has a red X on it because somebody dropped it on the floor.
Oh my.
And what happens is a sudden shock, there's an internal resistance collar inside here made of ceramic. And if you drop it, you'll crack it. And so I have a new tool that's relatively new, and I put spark plugs on there that appear fine. You put them on the tester, they spark fine. I said, let's go flying. But then they start failing. And the problem is that resistor is probably cracked. So I had this tool, I can put it on there and I can check resistance to within just a few ohms. And it's hard to do a good looking plug, you know, that costs that much money to put a red X on it. But I share it in such a manner as this. And so,
It's $64,000 question. isn't
yes.
it? Every 250 hours, you gotta pull this thing
No,
down.
no, that's not true. No, this is, the 250 hours is what's on that engine
Okay,
since rebuilt, and it's in great shape.
okay.
I expect to get at least 1,000, maybe 1,200 hours out of it. Maybe have to, within there, because these are the weakest parts, the cylinders, depending upon how I maintain them, I could stretch those out. I mean, no, not, it's the opposite. They may show sign of replacement, need for replacement in 600 hours. It depends. Depends on a lot of things, like that shock cooling, that'll kill a cylinder in time. It takes a while for it to really affect it. But I'm gentle with power application and all the other things that we.
So it's just like a sports car. Do you want to step on it? You're gonna pay.
Yeah, that's right. Yeah.
So I thought you started this by saying every 250 hours, you had to pull them down.
Oh, no.
What's the time? that
There's
you-
TBO is what you're referring to, time before overhaul.
Time of war.
Okay, TBO does not exist on these early engines.
Okay, it doesn't
It's
exist.
based on condition.
Okay.
So on condition is judged by your your IA, which I am.
Okay.
And so if I look at an engine with time on it, it doesn't even sometimes it doesn't have to have a lot of time on it. But if I see it's gone through oil, it's fouling plugs, all sorts of signs of not good wear, it's only going to get worse. It doesn't get better. Then I might say, you know, it's time for this engine to come apart.
Okay.
I said, what's this all about? He says, well, he laughed. He said, I understand you got the perfect man cave. I go, oh, that's nice. And one thing led to another, and they came over, 2 cars, 4 people, next day, with their little, looked like iPads, and they walked around. The Cub was in here, this airplane was. And I said, I'll clean it up. They go, no, leave it just like it is. And they came back a couple weeks later after I got permission from the airport management. Trucks and food trucks and lights and mirror, all this stuff. Spent the whole day filming. And at the beginning of the day, he says, you ever been in front of a camera? I said, yeah, I used to do that with the airship stuff and media. They say, we'll give you $700 to say one line. I said, yeah, I got $700 to say. But it took all day because they had to do all these takes. But if you go to my website, flyaloft.com, and I'll give you guys pens with that address. That video is on the biplane ride side of the website. And I'll talk about the website real quick. So you go there, you got biplane rides, you got photography. Biplane rides has a lot of stuff on it, mostly about biplane rides and stuff. And the photography thing's got a fair amount. I do not offer services anymore. However, I'm marketing my stock photography. And so there's the gallery, click on the gallery, and it takes you to another website, my website, for images and videos. And there's drop-down lists, and there's more stuff on there than you can imagine. All over Maryland, South Florida, New York City's got a great folder.
I've got one of your pictures of the Empire State Building.
Yeah, so that image won all sorts of awards.
Yeah.
And that's a whole other story how I got that, you know, and from a blimp, obviously. But anyway, so hey, you're welcome to visit that. But I have some.
What were the 7 words you had to say?
Oh.
In the video.
Well, maybe I'll say you have to go see it for yourself. So anyway, this is the man cave. This is my shop. We are completing the 100-hour, the annual inspection, but technically it's the same as a 100-hour inspection. So every year we have to open up any airplane. All airplanes have to go through this. I'm very, as they say, anal about my maintenance, and even though I'm licensed to sign off my own inspection, I don't do it. I'll do the A&P mechanical wrench pulling, but I got a good buddy who's retired FAA head of the maintenance department who's from this area, and he's agreed, this will be the third year, to come over. In fact, he'll be here this afternoon. He looks at my work and he's looking for issues. And that's the whole idea. I want you to find problems with my work. And he enjoys it because we're such perfectionists. And he just loves the airplane in general. So we've gone through all the wing panels. This is the last one to inspect for him. So he gets up on my custom stand, which moves around anywhere on the wing. And he inspects all components with lights and mirrors and cameras and so forth. It's a wood wing with metal attach points and so forth, but it's all wood covered in fabric. No, you can't see the wood. It's wood's under the fabric. So it's a polyester fabric over the wood ribs, which are attached to the spars. And then the attach points are made of metal. And this airplane's unique in the fact that we, like fools, chose to polish our struts. This is not chrome. This is polished aluminum. You ever polish silverware and get fussy about it? Look at all the acreage we got here. So the components, it has to be either polished or painted requirement. It's got to be protected one way or another. So
What's the ball, what do you use?
I am on a really nice, expensive system. But what we've been doing lately is after we there's 3 different procedures to it. We put the new
Polyester.
ceramic coat.
Oh, yeah, yeah.
Yes, ceramic. And I did it on these outboard end struts last year to see if it's even gonna work on a polished surface. It's meant for a painted surface. And I couldn't believe it. My goal is to keep the bugs, I can wipe the bugs off. And when you put that stuff on a polished surface, the rags are slippery as can be, but how long does it last is the question. Last year, it lasted all season. It was a big help. So we did it, repolished this year, and it's on everything. So we'll see what happens. But this paint is the early Emron paint. Which the early Emron paint, if you know the history of polyurethane paints, was deadly. It was killing people like crazy because it was so good. It's got heavy plastic sizers in it. It's very flexible, very, very durable. And back then, it was a hit for trucks and airplanes because it gives you that wet look and it stays on there for a long time. It's a bitch to repair because of its composite, it's component. But now, things have changed, they've reduced the good stuff in it, probably saved a few lives, but now nobody uses it, it's not even legal to use it on fabric anymore. So, unless somebody's got a can of the old stuff, I can't put Emron back on here. And there's the long story behind all of that is, because it cracks, the new stuff cracks. When it cracks, it lets water in. When water gets in, it deteriorates the fabric. And all these little details one has to worry about with airplanes. So here's the engine in one piece. You can go ahead and motor on around if you like. I'm about to pull all these valve covers off and check the clearance.
It could be out of the way this way.
So this originally had a 220 on it, like you saw in the video. This is a 300 horse.
You're fine.
Look at on the table. I also have a cowling that's on here. You'll see on the website pictures of it with the cowling on, which really helps things out. This propeller is kind of rare because of its dimension. It's only been cut once. So as they go through overhaul, they become smaller. And the smaller they become, the less desirable because the less performance you get. It's called a Dash 10. The Dash 9, which this used to be before the last overhaul, is the most desirable. So it's mostly the diameter, the disc, and I've flown this airplane with a Dash 15 on there, and It's okay, it was polished, looked good. I'll put this dash 10 on here, it's just, it throws more air over the top of the wing, it does a lot. But the tips are going faster because the length is long. And I don't like a noisy prop on takeoff, so I've adjusted the prop governor so that I have actually a spring in the control. If I go full forward, they will start barking, but I just let off a little bit and it reduces RPM by 50, and they go quieter. Now you can hear the engine. Because when you hear airplanes flying, you're not hearing the engine, you're hearing the prop case, beside the jet. So, this engine's well worth hearing. So, the airplane has disc brakes nowadays. We put wood floors in there. This airplane has Wi-Fi.
Wi-Fi.
It's got Wi-Fi. Here, let me set it up so you can take a peek in there.
You'll probably get better reception when you're up than we get on the ground.
Oh, yeah, Wi-Fi. This is, well, I use it because I have what we call an ADS-B system on that interrogates other airplanes. And I can gather the info and display it on that instrument, and then I can put it on an iPhone and an iPad. So I can see other aircraft, the details, who they are, where they're going. And everything is right there. And so this is the lower cowling. The top cowling's up in the loft there. And they're both kind of awkward to handle because they're a bit delicate. I've rebuilt these things over the last couple of years. This is new sheet metal here, this middle section. Made all that from scratch. And so the top cowling's bigger than this, higher than this, and far more awkward. So I built a system up in the ceiling there, which is similar to what we used when I was a farm boy, picking hay off a wagon, dropping down the forks, and they gather the bales, and up it went, and then back into the barn loft. And that's the same thing I built there to lift the cowling off. I can remove and install the cowling by myself. Works out well. So the reason for the cowling is, you'll notice around the cylinders there's some folded rubber. Those are baffles. So as air rams into the front of the engine, it's forced around the cylinders because it's sealed off with those baffles and of course the cowling. So cooling has really improved on this application, especially compared to those who don't have cowling. And it looks better and it goes a little faster. And so it's heavier, but it really does make a difference in appearance. And this jury strut here, actually it's called a javelin. This is really neat. If you go to the website, you'll see video taken from this camera. It's a 360 cinema. It's unbelievable the quality that it captures. And by the way, there's a MPT production underway right now that's going to star this airplane. How many people have seen MPT's production, Chesapeake by Air?
Oh, yeah.
I've seen
Yeah.
that.
Okay. Well, that's been a real popular production for years, and they're still using it for fundraising. They decided last year they're going to do Maryland by Air, and they organized the event or the project. They got the same producer. The same producer that did Maryland or Chesapeake by Air is going to do this one, Maryland by Air, and so they got it all lined up, ready to start, and then someone introduced them to me. And one of their reps actually showed up here as a guest at the airport. I was in here fiddling with the airplane. She was very nice and very interested, and she went to the website to see the imagery and told her boss, who's the head of MPT in Owens Mills, who called me, he says, "Hunter, what's this website?" I said, "Well, it's the kind of stuff I do." He says, "We're doing this new project, the biggest MPT's ever done. It's called Maryland by Air. And we need to build a coffee table book of aerial imagery of the state of Maryland. You got everything we need." I said, "Thank you." but you're not gonna get it for free. So don't even think about it. And they kept asking for it for free. Anyway, we eventually reached an agreement. And then he says, this airplane you have, is it available? I said, maybe. So we finally narrowed it down. This is going to be the star of the show. So instead of flying like the Chesapeake, you didn't know what you were in, you were just elevated. You're gonna fly Maryland from this airplane. And so we did just under 5 hours of formation flying with a helicopter that had a big Cinemax on the nose, and great footage. In fact, I'll be posting more of that, of this airplane over at Delmarva, Oxford, St. Michael's, Tillman, and Ocean City, Aztec, and then we went out to Poplar Island, Thomas Point Lighthouse, Annapolis, Baltimore, you know, with the airplane in the foreground. And then they got a lot from below, looking up at the sky with the airplane. And they're going to use those clips for the Western Maryland part of the show. And another thing, if you go to the website, on the biplane side, you'll see all these icons with attachments, and you'll see a icon for Maryland by Air. You click on that, it'll show you a sample, is what they call it, some of the footage. It includes some footage from this camera as we were approaching altitude. And so we're surprised at the quality. We're not sure we're going to use it. I shouldn't say we, it's the producer doing this. But the show's going to premiere in the fall at the Maryland Science Center at the IMAX Theater. And it'll be shown there for 10 years. Of course, it'll be on TV. And they've promised me a copy that I can share on the Eastern Shore at whatever venue I want to do. So let's see if that
I
comes
think
true or not.
Chesapeake Forum field trip to the IMAX. I think that could be pretty good.
Yeah, that could be interesting.
That would be fun to get a group of us over there.
Yeah, that's a great, you follow up on that.
I will.
And so anyway, it's kind of neat. They came out of the blue and they are now working on the book. So we are busy adding imagery of Maryland to our gallery, which you have access to. And you're welcome to visit.
Spark plug?
So I want to give out, I want you guys to one at a time come up and take a look in the cockpit and see some of the stuff. Let me get a light. And as you do, I'm going to hand you a souvenir. Go ahead, you're first. Just step up there, take a look. I fly from the rear cockpit. Hmm? It's got the website. Does it have the website? Yeah. Yeah, okay.
Same as your license.